If 1800 centimeters squared of material is available to make a box with a square base and an open top, we're going to find the largest possible volume of the box. So, since we need to maximize the volume of the box, we need to come up with an equation for the volume, and that's what we're going to take the derivative of. So, we have the volume of a box is going to be the length times the width times the height. In this case, because we have a square base, the length and the width are going to be the same. So I have x times x, which is x squared, and then times the height. Now, when we take the derivative, we want all of the variables to be the same. So I'm going to use the information that they give us about the surface area to find h and plug it in so we have everything in terms of x. So if I look at the surface area of this box, the surface area is going to be the area of each side added up. Now remember, this is going to be an open top box, so there's really only 5 sides to consider. The bottom would have a surface area of x squared, and then we have 4 sides that are the same. The sides are going to have an area of x times h, and there's 4 of them. So we have 4xh. So this is going to be our surface area formula for this box. And we know that we have 1800 centimeters of material for that. So I'm going to set this equal to 1800 centimeters squared. And this is what I'm going to use to solve for h and substitute it into our volume equation so that we have everything in terms of x. So when I solve this for h, I'm going to get 1800 minus x squared, and then I divide by 4x. So this is my h. So now I have to go back and substitute this h in here so I have everything in terms of x. So I have the volume is equal to x squared, and then substituting h, I get 1800 minus x squared all over 4x. I'm going to simplify this a bit. I am going to multiply through by x squared, so I have x, whoops, let me do this first. I have 1800 x squared minus x to the 4th when I distribute the x squared all over 4x. And I can simplify this and write, let's see, that would be 450x if I take the 4x and divide it into the 1800x squared. And then when I take x to the 4th divided by 4x, I get x to the 3rd divided by 4. So here's our equation for the volume, and this is what we want to maximize. So I'm going to find the derivative, set it equal to 0, and find critical values, and hopefully we'll find a maximum value. So I have the derivative of the volume is going to be 450. I'm looking at taking the derivative of this first, and then I'm going to take the derivative of this next. So I have minus 3x squared over 4. So here's my volume. Now I want to find our critical values. So I'm going to set this equal to 0, and I'm going to solve for x. So let's see, that will give me 3x squared over 4 is equal to 450. And then I'm going to multiply both sides by 4/3. And let's see, that's going to give me 600. So I have x squared is equal to 600. So x is going to be plus or minus the square root of 600. And when you put that in decimal form, you get plus or minus, let's see, 24 0.494897. I'm trying to keep as many decimals as I can so I don't have any rounding errors, and I'll just wait until the end if I want to round. All right, so we have two critical values. Now we can find which one is the max and which one is the minimum a couple different ways. We can graph it on our calculator and see where the minimum value is and verify that it's at one of those values. Or you can make a sign chart. If you do that by hand and you make a sign chart, then what you want to do, I have negative 24.494897 over here. And then just like on the number line, then I would have the positive 24.494897 over here. And then I want to pick test points on each of these intervals. So I have this interval from from minus infinity up to the negative 24. Then I have everything in between. And then I have from 24 and up. So to positive infinity. So to make this sign chart, what I want to do is plug in a value on each of those intervals. It doesn't matter what it is, just make sure you're plugging in something that's on the interval but not the critical value. This is 0 if I plug that in. So if I plug in, let's say I use as my first test point, let's say I use negative 30. That's definitely on this first interval on the left. Now, if I plug negative 30 into my derivative, I'm going to get a negative number. So this interval is negative, which means on this interval, it's a decreasing interval. Now, I'm going to plug something between negative 24 and positive 24. So I'm going to use my second test point. I'm going to use 0. That will make the arithmetic easier. So when I plug in 0, I get 450, and that's a positive number. So on this interval, it's going to be positive, which means it's an increasing interval. Okay. Then on the last interval, I'll plug in the test point x is equal to positive 30. When I plug in positive 30 into the derivative, I get a negative number. So this is decreasing. So now when I look at this, if I line this up, these are my critical values, so I'm really interested in seeing what happens here. I'm going to highlight them pretty big. Okay, on the interval from minus infinity up to negative 24, I'm decreasing. And then after I hit the negative 24 critical value, then I start to increase. So this value is a minimum. Now on the next interval, I'm increasing. So that's going to be look like this. And then when I hit that positive 24 critical value, then I start to decrease. So at this value, we're going to have a maximum. So the question wants us to maximize the volume. So which means we're going to use x equals the positive 24.494897. That's our maximum. Okay, now in order to find the volume of the box, now I know one of the dimensions. That's the bottom part, the x by x. I know what the dimensions are for the bottom of the box, but I also need to know the height of the box in order to find that volume that's maximized. This x maximizes the volume, so we still have to find the height. Now we found the height up above when we solved for h, and we got 1800 minus x squared over 4x. So what I'm going to do to find my height is I'm going to take my x that I found that maximizes the volume, and I'm going to put it in for my x here and here to find the corresponding height that goes with that. Okay, now when I plug that in, I'm going to get that my height for the box is 12.247444871. So now I have the dimensions that I need to find the volume. The volume of the box is x squared, that's my square base, and then times the height. So I'm going to take that 24 critical value, and I'm going to multiply, or I'm going to square it first, and then I'm going to multiply it by my height. And what you end up getting when you find the volume using those values, you're going to get 7,348.469228 centimeters cubed. So that will be the biggest volume you could get with 1,800 square centimeters of materials.